Okay, so to do this lab, the first thing we need to really do is measure out a mass of our sodium carbonate. So again, put the weighing tray on the thing, zero it out. I have some leftover sodium carbonate here. We really don't want much. We want between 0.1 and 0.2 grams. So that's not gonna be very much. Again, getting it exact is not important, but knowing the amount. So record your volume there and you're good. So then we take this, put it into our flask. Then we need to go get some distilled water. 21 milliliters of distilled water. You can pour it from the bottle. You can use the rinse bottle as I'm doing here. Close enough. Remember to measure. Remember to measure and record this volume, and then you're going to mix them together. All right. There is still some powder on the bottom. Swirl, 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 swirl. All right. A little bit left, a little bit more stirring. Okay. Now that it's all dissolved, we have our solution. We know the mass of our solute, but remember that when you're trying to find molarity, which is one of the things I'm asking for, when you're trying to find molarity of a solution, you need to know the volume of the solution, not the solvent that you put in it. So let's pour this back into our graduated cylinder. And again, we are going to measure the volume here. It will probably have changed from the amount of solvent that you put in here because we've mixed something with it. Once you measure this volume, we're going to pour it back into the beaker, and we go for step 2, which is our iron nitrate solution. So with our iron nitrate solution, you need roughly about 20 milliliters of this. Depends on how much of the solute you have. You could use stoichiometry to calculate that if you wish, but we want to make sure we have an excess of it. So I'm going to measure out roughly 20 milliliters of it. This, by the way, is 0.1 molar iron nitrate because it's what I have on hand. 0.1 molar would actually be a whole lot better for this, but I don't have that on hand. All right, so again, now for the reaction. We have our mixture of sodium carbonate. We have a mixture of iron nitrate in the solution, 0.1 molar. We're gonna mix them together. And you immediately can see that there is a precipitation reaction going on here. We're gonna let this settle out. All right, little quick bonus footage. This is what I did previously. This is what I did here. Notice the difference. There's a contaminant somewhere messing this up. I'm wondering if somebody put regular tap water in my distilled water, if tap water makes a difference. But that is why I'm leaving that up as extra credit. All right, this is not that hard to do. Take your filter paper, put it on there, see its mass. Take the mass, write it on the filter paper in pencil because it's going to get wet. Put your initials on that so you know. And so then you go and you take your filter paper and you fold it in half. Fold in half again. If we open it up to this first one, that's where my measurements are. We do not open it up to the middle. And then we open it up to here. And that's what's going to go into the cone. So let's see what we have here. First, we have the cone that we made earlier. It needs to be seated into here. So we're going to take the little rinse bottle, push it down. It is now seated into there. All right, taking a look at this. It is still clear. We're going to start filtering it. And you can see that it's coming out. And it's still pretty clear. So we have a chemical equation here of what's going on. We have the sodium carbonate that we had earlier combined with the 0.1 molar iron nitrate. And we made iron carbonate as a precipitant. So first thing we obviously have to do is balance the equation. We're looking up here, we have 2 sodiums. So we need 2 sodiums over here. Now we have 2 nitrites, we have 2 nitrites. We have 1 carbonate, and we have, 2 sodiums there. So again, let's see. That looks like that took care of the equation. It is now balanced. So let's talk about some of the things we measured. We got a filter paper mass, we have a mass of a sodium carbonate, we have the final volume of our solution. What I'm looking for is the molarity of the solution, which means I need the number of moles of sodium carbonate, which means I need to find the molar mass of the sodium carbonate. So, to find the molar mass, we simply just add up all the atomic masses off the periodic table. We have sodium, carbon, and oxygen. If we go to our periodic table, we will find that the sodium has an atomic mass of 22.9898, carbon 12.0108, and then oxygen obviously is going to be 15.9994. Okay, but that's not the end of the story. Looking at the formula, there are 2 sodiums and 3 oxygens. So you need to remember to multiply that by 2, that by 3, and add that all up together. This is where you get out your handy dandy calculator, and you do such. 22.9898 times 2 plus, you don't need to listen to me do math, but again, we're just adding them all together. And we get a total of 105.9886. That number you will put right here. 105.986. So now knowing that number and knowing how many grams of sodium carbonate is, we can find the number of moles. You have 0.4 grams of sodium carbonate. We know from the molar mass right here that for every 105.9886 grams is 1 mole. So 0.4 divided by our previous answer gives us 0.0037739 moles. Okay, so that's the number that we would put down right here. Okay, so to find molarity, molarity is the number of moles per liter. So we have the number of moles, 0.00 again. And how many liters of solution did we have? That's that number right here. Remember, that is in milliliters, and that needs to be converted to liters. And so again, we just do the math. Two sig figs. And there is our molarity. Okay, so last part here, theoretical yield. We have our balanced chemical equation up there, and we need to find our theoretical yield. So that means with a given amount of this, 0.4 grams, the question is, how many grams of the iron carbonate should we be producing? So we start with our known. We start with 0.4 grams of sodium carbonate. Okay. Then, using the molar mass that we found earlier of sodium carbonate, for every 105.9886 grams, we produce 1 mole of sodium carbonate. So now we're in moles of sodium carbonate. From there, we need to convert to moles of iron carbonate. And this is simple. This is a 1-to-1 molar ratio. So 1 mole of sodium carbonate produces 1 mole of iron carbonate. And now finally, having calculated previously off camera the amount, the molar mass of iron carbonate, I need to use that number to convert to grams. So we know that for every 1 mole of iron carbonate, we produce 115.854 grams. And again, we're just going to do that math, and that math will give us our answer, at least the theoretical amount. Now, whether or not we recover that amount back, probably not. And that's why we're going to calculate the theoretical yield later. And we get 2 sig figs, 0.44. And so that would be the number we put down here. Okay, so we expect that this number here will be slightly less. All right, future me here. Added to the video, a couple things. 1, made a mistake. Yes, I know that 43 milliliters is 0.04 liters, not 0.004. So I made that mistake. Divide by 1,000, not 10,000. Second thing is, remember earlier when the video I said we're having issues? Well, it's taken me all day, but I figured out what those issues are. So let me turn the camera around and show you. So to recap what the issues were. This is what we should have made. Notice it's still clear. That's because I do not have an excess of the iron nitrate. All the iron nitrate, all the iron is going into producing the iron carbonate. As it took me a lot of figuring things out, I was like, is my water contaminated? So I went and I checked with the water, and that was not the issue. What happened was I had made up a sample of this, and this used to look just like that. I made up a sample of it, and it looked exactly the same. And I kept adding the iron nitrate because I wanted to have an excess, or at least I thought I wanted to have an excess of the iron nitrate. And it turned to this. And I'm like, what? Let me show the equation. So as adding an excess of this, suddenly my precipitate disappeared. Not only that, adding an excess to this, I started getting bubbles. And there ain't no bubbles in that equation. So what's going on? I had it down to 2 things, and then I called in a favor. I have a friend of mine, PhD from Rice University, so good friend. But I had it down to 2 possibilities. First possibility was I was making an acid. Second possibility was we're going from iron 2 to iron 3, and that could cause something. Well, it turns out it's iron nitrate. And when you have an excess of it, it produces nitric acid. And the nitric acid then reacts with the carbonate, turns into CO2, and so all my product just goes up right as a gas. Why did this happen? This totally happened here because normally in a chemistry lab, we do this from, get my nice poster here. Normally in a chemistry lab, we do this with a copper sulfate or something boring like that. And I wanted to do something that didn't make a white precipitant, but something colorful. So I was doing something extra and special that I was trying to be special. Well, there's a reason why this lab isn't usually done this way. Anyway, hope you guys have a good day.